Hey guys, so I wanted to give you a little glimpse into what I've been working on for the last month or so. This is a game called Solomon's Key. It came out on the NES by a company called Tecmo in 1987. That's Tecmo, not Tecmone. This is one of my favorite games from childhood. I had some work done on my car about a month ago, and I was stuck at home for about a week and a half, and I was playing this, and I wanted to get more into it, so I started mapping out the RAM and the ROM, and I started disassembling the assembly code to figure out, what I could do. I had already made all new levels using a level editor that came out for the NES version that edits the ROM. And I wanted to add some more enemies, I wanted to add some more specific behaviors, I wanted to add new items. I wanted to make a deluxe version out of it. And unfortunately, the issue wasn't wading through the assembly code. I didn't really have an issue doing that. The problem is that this game is built very close to the limits of the NES. And when I say the limits, I mean sprites on screen, CPU time used in between frames, things that you can't really expand upon without a whole hell of a lot of optimization. So after about 5 days of disassembling the ROM, I decided, hey, you know what, this is probably just going to be easier if I just code this from scratch in, a modern language on a modern computer. So that's what I did. So just to kind of show you what the game entails, there's a key and there's a door, and you are this little green wizard named Dana, played by Dana Carvey. No, just kidding. Your job is to find the key. The key opens the door, and then you go and you find the door, and you go in the door. But there's also items that you can find, like this hidden bell here, there's fairies to collect, and there's obviously enemies and obstacles to dodge. It's a pretty straightforward game, though. Every level fits entirely on the screen. There's no scrolling, and in the original, there's never more than like 15 or so enemies or other items on screen at the same time. Alright, so let me show you what I've been working on for the last month or so. So this is Solomon's Key X. The X stands for extra. The first thing is that we have like a modern game, we actually have a menu system, so like you can change the scale, you can do full screen, you can change the controls, you can edit the key bindings, it works with a keyboard or a gamepad of any standard Windows variety. And there's also different stories. So the idea is that Classic is the original game, everything is as vanilla as it was on the NES. Classic Plus gives you some of the new features and some hidden bonus levels and some additional secrets, but it's still the same thing. And then I plan on having a story that's completely all new, a whole new adventure, all new levels, all new enemy types, etc. Which I'm actually mostly done with because I've actually been building levels prior to building the Windows game. So the code can actually import levels from the original NES. It'll open up the ROM and read the right offset and interpret the level data. So I can port levels over really quickly, but I can also create them from scratch using a whole bunch of new gameplay elements I've added to the engine and store them in a new format as well. And then test is just for my test levels. I've created a bunch of rooms to test physics and other aspects of the game. But let me start it up here. The other thing is that there's a save slot system. So one of the issues with the original was it was extremely difficult because you technically have to beat the entire game on only one continue. In other words, you don't get any continues. There is a very basic cheat code to get you past the game over to where you were, but it shouldn't have to be a cheat code. You should be able to continue from where you left off like any standard game. But if you do create a new game, another feature that I've added is difficulty settings. So if you thought the original was difficult, you could go on easy mode and you'll start the game off in a slightly better position to beat it in an entire run. So if I go ahead and start the level here, this is room 1. It's the same level as the original, and you'll notice it looks very similar. It's pretty much the same thing. Now there are some parts that are not 100% accurate that I'm still working on, But for the most part, this is there. This is, so here's room 2. So I'm very happy with it thus far. Here's room 3. Just for comparison's sake. Shit. I think in the original those go around the thing in the other direction. Either way, I'll do it. Fuck. Just do that. Fuck. Now I understand why this game is so difficult. I swear to God I will accomplish this. Let's lock them in here. It's playing somewhat janky because I'm screen capturing at the same time, but I don't believe it's at a point where it's exactly pixel perfect yet, but it should be very close. So now that that's done, let me show you everything else that I've put into it. So you might be saying, well, that's great, but why wouldn't you just play that in an emulator? Like, why would you take a month to port the game to Windows when it looks exactly the same? So aside from the other story campaigns, missions, whatever you want to call them, I've added so many features to this, including a built-in level editor. So let's quit the game and go into the fuck. Alright, so this is a relatively quiet room, so this will give us a chance to talk. Let me just turn the volume down on the music. So real quick about the game, it runs on .NET Core, which means that it runs on Windows, Mac, Linux, Android, or iOS if I want it to. I've written pretty much all the routines from scratch. I'm using Monogame, formerly XNA, to handle the audio and sound and input. But outside of that, everything I've had to write from scratch, even including the text routines and the font management, because what was built in was not working for me. And then in the course of building the engine, I've had to add a shit ton of diagnostic features, which I think are really interesting to look at. So I'm going to take you into debug mode. So to get to debug mode, we pull up the menu and type the word debug. And you can see there's all kinds of shit on the screen now. So one of the first things that I'm going to do is, if you notice, I'm about to run out of time, so I'm going to hit F2 a bunch of times, which are going to give me more than enough life to sit here and discuss what's going on. So on the screen, there's a bunch of new information. On the right here, where it says X and Y, those are going to be my X and Y position in white and velocity in blue. So if I jump, you can see that, you know, that moves, and there's the X position. That's great. So above the position, there's some flags, so that O means that I'm on a floor. If I jump, you'll see the J and then the F, which are jumping and falling, and then C is for crouching. And the UDLR, that's collision detection with different things. So if I push against the right wall, you can see the R is lit up. To the left of that are the camera coordinates, which I'll get into in a second. You might be thinking, camera? What camera? This is a fucking basic-ass 2D game. Why is there a camera? And then to the left of that, in the upper left, is the spawn timer, which controls enemy spawns throughout the level. So now I'm going to hit F10, which is going to go... Okay, so apparently F10 also makes my screen recorder stop. So I fixed that. And now if I hit F10... we're in collision mode, and you probably didn't see anything happen, but if you notice, if you look around Dana, as he moves, there's these dots, these cyan dots, and those are actually the collision sensors that look for the floor and look for the wall. And if I push against this wall, you can see that it kind of highlights. I can hit B for boxes mode. Let me go to a different level. So I'm actually gonna go back to let's go to this level real quick. So if I hit B, it turns on collision boxes. So these are the boxes that are used for collision detection with enemies, with items, various things. Let me kill this guy because he's annoying. And I can also hit Shift B, which turns on, let me turn boxes off. So Shift B turns on hurt boxes. So these little red boxes around all the enemies, those are the actual hitbox that counts for Dana getting hurt by an enemy. I can also hit R and turn on routine counters. So these numbers that now appear on everything, like if you look at the dragon in the top right, it's alternating between 1 and 5. So those are the actual routines within those objects. So 1 is the dragon walking, 5 means that it's stopping at the edge of a floor, and you know there's all kinds of, like, here, let me go kill this, and it'll turn into a different number as it's falling. So actually here, let me get it to spit. So 2 and 3 are attack, and then 4 is falling. And I can hit M to turn on the music tracker details. So I'll talk about the music and the audio in a second. Alright, let's go to another level. So this is another test level. This is testing the demon head enemy. All of the enemies in my engine come in 4 different speeds. The original had 2 to 3, sometimes 1 depending on the enemy type. And I can have a lot more enemies on the screen. I can have hundreds of enemies on the screen if I want. So let's go through here, and let's come back to our testing hub. So this is the hub for my test levels. The first thing you'll notice is that there's 8 different doors. Why are there 8 doors? Well, in my engine, there can be multiple doors with different exits. They don't always have to be numbered like that. That's just there to help me in my testing. This black potion here is a scripted action, so when I do that, it's actually going to break a piece out of the bottom of the level, and a fairy's going to shoot out along with a 1-up, so let me do that. So that's a scripted action. And let's take a look at Room 3. Room 3's got a bunch of new stuff. So the first thing I want to draw attention to is the music. Let me turn the music volume back up. If you listen to it, it's really quiet and tranquil. You can hear the drums and you can hear the lead, but you don't hear the bass. And what this is dynamic audio effect. So if I walk to the right, you'll notice that the music subtly changes as Dana moves across the level. So here, I'm going to be quiet and do it. So the other obvious feature is that this level is larger than the screen, so there is scrolling, and there is camera controls. Like for example, right now the camera is locked up here, but if I start exploring down here, the camera unlocks and I can come down here. Whoa. This is another new feature. I'm going to turn the music down real quick. This is another new feature, which are frozen blocks or frozen items, which can be melted with fire. Or fireballs, or, you know, whatever you see fit. So there's also... Listen to the low time music. Listen to how it shifts as the time runs out. You can hear that the drums or the noise track and the lead would get progressively louder as time is running out. So this blue door is a warp door, so this takes you someplace else on the current level. I feel like Terry Davis narrating Temple OS. It's like, it's got all these features in here, but... So the game has an integrated level editor. So in any level with debug mode on, you just hit F11, and now you're in the editor. So this is the initial layout of the room, and you can just pick something up and start, editing it. Here's the blocks. You can hit O for objects mode and move these things around. Like, let's say we want to put that guy there, and let's put that guy over there. You can do the tile editor, so like, let's say I want to put one of these things over here, whatever. You can do that, and then when you're all done, you hit F3, and that saves the level, and then you can just start the level from there and see how it pans out. Okay, maybe I want to move that guy up because he's eventually going to shoot through here, so hit F11, go into objects mode, move him up, maybe we put him here. That looks good, so we can test that out. So let's go back into the editor. So there's level mode, which is used to change the actual foreground, the blocks that make up the level. So in level mode, I can pick up a block with right click, I can paint them, I can make rectangles, like if I want to fill a whole area with this I can, like if I want to do that. I can also do the same thing in reverse, so get rid of all of that. I can also just hit delete and delete the entire layout if I don't like what's there, and then I can just start making a level around that. So let's just put some bricks over here, let's put a key over here, one key, let's put a door over there, and let's save that. And if I start the level, the first thing is that I didn't remove the spawn point, so those are still shooting in from up there. So we can do S for spawns mode, and you can see up here there's a spawn with this guy, and I can move that over here. I can do, let's just delete it for now, and let's go into the background. I can change the background, so let's say let's do bricks, and let's put the Zodiac image there. So I guess that's a fish, Pisces. No, that's a goat, Virgo. I don't know. This looks like Virgo. I don't know what that's an image of. Actually, here, let's change this back to the stucco background, and then put it maybe like here. That looks better. And then, oh no, it doesn't. Let's put it here. There we go. That looks good. And then there's keys mode, which links keys to doors. There's doors mode, which determines where the door is going, what room it's going to go into. So let's say that this door leads to room, I don't know, let's say 15 for some reason. We can save that. Let's add some enemies. So let's put a panel monster here. Let's put another enemy over here. We can do another panel monster. We can do some ghosts. Let's find some ghosts. Here we go. Let's put one guy here. Let's put another guy here. Let's flip him around. Let's change the graphics on him so he's that guy instead. Let's also throw in some of these guys. Where are they? Some of these guys, let's set their speed to 4 and just shove them up here. So this will be interesting. So when I start the level, this guy's just going to bear, woo! I still have fireballs from the previous. Oh shit, why did I not shoot the fireball at that guy? So there's level mode, there's objects mode, there's spawns mode, there's magic mode, there's cameras mode, there's keys mode, there's doors mode. But all of the interaction with this game is through the game. There's no external editor. I don't sit around and edit config files. I don't do level layouts in a text editor. Everything is immediately buildable and playable in a very close loop. So 3 features that you need to build into any game engine that you're building are going to be, number 1, the ability to see debug information. So in other words, the ability to see all the stuff. That's very important that you, as you're playing, you have a good situational awareness of what's happening within the engine. The other feature that I would never develop a game without is the ability to change variables. So instead of using some fancy pants thing like I am GUI, I just have what are called dev variables. Let me go to a different room here real quick. So I have what are called dev variables. So if I hit some of these buttons over here, so you'll see at the bottom I have A, B, C, and D, and these are just general purpose variables in my code that don't correspond to anything, but I can change them through the UI. So if I'm writing the code for a new enemy behavior or something else and I don't know exactly what value to use, I'll have it read from a dev variable, and that way while I'm in the game I can sit there and tweak it. So B might be, you know, the hitbox width on an enemy, or maybe the number of ticks it stays in a specific state for. And that way, even if I don't know what numbers and values to use while I'm writing the code, I just know that the enemy has to stop for some amount of time. I'll leave a dev variable in as a placeholder, and then when I'm actually testing it, I can figure out exactly how it should feel, how it should behave. And then once I know what the actual value should be, like let's say it's 0f, then I know, and then I can hard code that in and remove the variable. The third thing that's absolutely critical to game development is the ability to pause and step through the game. So I can hit F7 at any point to freeze the game, and then I can hit F9 to advance the game by 1 tick. And this is very important because as you do game development, you're going to run into scenarios that only exist for a single frame. So being able to freeze the game and then step through it, either a single frame at a time or by pressing F8 until, you know, you need, like let's say I needed to set a breakpoint as soon as those fireballs hit the wall. I could just sit there and get right until about there. I went 1 frame too far, but you know, you see what I'm saying. You get right there, and then you can set a breakpoint, and then hit F9 to step through the game in 1 frame. If you need absolute control over what frame or what object you're breaking, you really need to build that into your game engine so that you can actually run through it at a speed that's manageable for testing. And then finally, let's look at the audio, because I did a lot of work in the audio department. Even though I could have just recorded the sounds and the music from the game into a WAV file and just thrown that into my game and said, you know, hey, here's the music, just loop this and everything will be great. I mean, it's super easy with this game. There's only 3 songs in the entire game. There's like a song for your normal levels, a song for your hidden levels, and then a song that plays once you beat in the game. So the main music for this game is broken into these first 2 sound clips, intro and music. The intro part plays once and the music part repeats. And the way that I've implemented it is that the first sound clip chains onto the second one. So if I go ahead and start playing the first clip, it plays, and then when it's done, it seamlessly transfers control to the next clip, as you can see here. Now if I go ahead and pause the original clip, if I pause intro, it pauses music because that's the sound that it's chained to. If I restart it, it restarts music. Now if I stop everything and start over again, it'll start with the intro again and then transfer back over. And you can see it sounds pretty seamless. You would have no idea that there's really 2 music files that make up this song. Now the other thing is that this music track here is actually 3 different tracks playing at once. So each of these 1000s is a different track. So in this case, the music track is made up of the lead voice, the bass voice, and the noise voice that they're using for drums here. And so what these numbers actually represent are the volume and pan levels of each of those tracks. So the way that we get dynamic music is that in the game, there's a routine for specific levels that updates the volume and pan of the individual tracks as different gameplay elements progress, either as Dana moves around the level, or as time runs out, or whatever you want it to be. There's just function pointers that are set up that say, hey, I need to know what my volume should be on this frame, and the game can respond with, anything necessary. Here's the 3 individual pieces. Here's the noise track. And then here's the So what I've done is I've exported every individual voice from the NES ROM and then processed it to sound really good when they're mixed together. So once again, here's the actual mix from the game. And same thing, like here's the music that plays when you're running out of time. So that's actually made up of this noise channel. And then this sawtooth channel. And then here's the other one. So we have a lot of control over what, how we want the audio to sound. This is an animation test. This isn't 100% accurate because this is running at the speed of the sound test and not the speed of a level, but I had to create my own animation system to track which frame of any given object's current animation should be playing at any given time, and allow for the animations to contain commands like having an end of animation or having an animation script being able to manipulate like the flip X or the flip Y flags, or to have each frame in an animation have its own unique offset. So some of these animations look incorrect because in the actual game the logic either has the frame shifted up or down or left or right. So like in the animations where an object is walking, a lot of times the object will actually shift up and down by 1 pixel on the y-axis to make it look like it's bobbing as it's walking, even though the frame itself is using all 16 by 16 pixels that are allocated to it. And so here's what the source code looks like. It's all C# obviously, and this is the layout. So this is everything that goes into building the level layout. Let me open an example. This is the demon head enemy. These are those blue heads that tumble around the screen. So as you can see here, it's just a class. It inherits the game object class, and then there's some subroutines for initializing the object, when it wraps around the screen, if it goes off the screen. Update gets called on every game tick. This is where all the actual logic is. And then render gets called when it's time to draw it to the screen, which this doesn't even have to be here because it's just calling the base class function. If I pull open the Solution Explorer over here, you can see that there's probably a couple dozen files that everything is sprawled out across. So here are the animation scripts. So this is part of the animation system. So you can see for any given animation, it's composed of a speed and a number of tiles. In some cases, there's also an X and a Y offset. But this is it. And you'll see interspersed throughout the actual tiles are commands like animation end, and it is my intent to open source this entire game. So there's a GitHub repository called SKX under my account Nill, and right now it just houses the README file, which is where I've been putting all the documentation as I've built things that need to be documented. But ultimately the entire source code will be in this GitHub repository, and you'll be able to download it, play with it, read it, whatever. But if this does interest you, feel free to comment below. I really would like some feedback on this. This is a very niche game. There aren't, you know, entire fan sites devoted to Solomon's Key. So I'm making this video mostly not only to keep you guys filled in on what I've been doing, but as kind of a, hey, look, this project exists, who wants to get involved type of video. So feel free to contact me if you have any questions, feedback, concerns, requests, and if not, then have a great day. Let's quit the game and go into the... fuck.